uh, like actually the purpose to have students learn algebra is not, it's not that someday we are going to use it. I think most times now you don't actually, at least you don't have to solve them. You maybe have to set it up, but it's a good material actually to learn think logically, um, uh, how to prove something is true. To have that mindset is that um, it has to be, there is a rational reason behind it. So when we say something is true, then I better have a way to back it up, which in terms of logic, that you have certain uh, rules that we agreed on, and then we actually when we um, go through uh, the proof process, we are actually using those rules, and we have to show why and how and why, what kind of rule we use, and how we use them. Hello, Rico, how are you doing?
Hello, I'm well, thank you.
Yeah, we just got started. Um, so this lecture is focused on linear equations. Uh, as I told Tiffany, that this actually, when algebra was introduced to Europe, and this actually is the heart uh, of algebra, and there are definitely many real life problems we can solve by basically solving uh, linear equations. But a lot of this, the reason actually we have students learn is not because they are going to use that, because nowadays we have computers, we have all kind of tools out there. So we, um, even if you are using linear equations, we don't mean we can just use computer solving it. We can just set it up and let the computer do the work. But the reason we have students learn linear algebras is actually to learn how to use the tools, uh, and how to think logically, and how to be able to make an argument. Say, okay, I think this is true. The reason for that is because this and this, that. There is a common rules that we all agreed on. Um, so basically, that's what I'm going to show you for this lecture. So any questions you have, you can just let me know, since we just like three of us, so uh, that'd be okay. Okay. Let me go to the next page, and so we're going to do a little overview about the rules of algebra. We actually only have about 10 rules of algebra. And given that algebra is so rich, there are so many things we can do in algebra, but the foundation actually is just pretty simple. We only have these 10 rules, and five of those, actually, four of them concerning about the properties of addition, and four of them concern about multiplication. Then we have two which actually going to involve both. So the first thing is the commutative property, and we think we pretty much take for granted, but that's where when we actually do algebra, we has to be in a way explicit to say, okay, what kind of rule we're using. So the commutative property like this is, we have two numbers, a plus b is the same as b plus a. That means as the operator, the order does not matter. And similarly for the multiplication, is a times b is the same as b times a. So we have that. And the next one is associative property. That means if you have three numbers or more, uh, it doesn't matter which two start. Um, we can start with the first two, or we can start the last two, or any of those. So it doesn't matter to which one to start. And similarly for multiplication, so we can do A, B times C, or we can just have B times C. And it does have some practical advantages. For example, on both sides. On this side, we can say 4 plus 9 plus 6. You can go 4 plus 9, which is 13, plus 6, 19. But it would be not easier to go 4 plus 6 first, because that's 10. 10 plus 9 is 19. So it would be a lot easier to go using 4 plus 6. Similarly, if you have something like, say, 4 times 7 times 5, then we can go 4 times 8 first. But it'd be a lot easier we do 4 times 5 first, which is 20. 20 times 7 is 140. So if we have to do calculation in our head, it's called mental math, then definitely we can use those rules to our advantage, called mental math. Okay, so we have those, and then we have so-called identity property. That means a number adding 0 is itself, does not change the value. And to the multiplications, A times 1 is A. And then we have the inverse property is a number adding its opposite is 0. And when we deal in multiplication is a number multiply its reciprocal is 1. So the last two is called distributive property is if we have B plus C, normally in order operation, we just say we do the parentheses first. But it also obeys this property that is A times B and plus A times C. And that's they called the right distributive property. And we also can do this from the, sorry, this is the left distributive property. We can also do it from the right. So it's C times A times C, then C times B, B times C. Okay, so that's basically all that's all in terms algebra, this 10 rules algebra. Everything else we have to base on those 10 rules. Okay, anything, are we okay so far? And
Yes. Yes.
okay, good. Just if you have any questions, you can ask. Unfortunately, nowadays in the school, they don't emphasize on that. And so that's where a lot of times the kids got confused because they don't know the rules. And if you don't know the rules, you'll be confused. And a lot of times they just they have to memorize the process, and that's not that easy to remember. But if you know the rules, then you don't have to memorize those processes. Okay, because you can just work it out on your own. Okay, next one. Okay, then we have those so-called properties of equality. We also have properties of inequality, but so far for this workshop, we just focus on equality. And if people are, if students are familiar with this, inequality become quite relatively easy. So properties of equality, we have this, is if we have an equation, if A is equal to B, then, and you can see that that's basically the structure of algebra is this if-then construct. So if A equal to B, then A plus C is equal to B plus C. That means if we have an equation, we can add exactly the same amount on both sides, and the equation is still true. So if this is true, and this one has to be true. Sorry, be true. Then we have the multiplication property is that if A is equal to B, then A times B, not A times B, is A times C is equal to B times C. So that means we can multiply the same amount on both sides. And the last one is called zero factor property, is that A times B equal to 0. If that's the case, then we know either A is equal to 0 or B equal to 0 or A equal to B equal to 0. So the way I'm writing 0 is like this. This is actually the engineering way of writing it, writing 0. Just make sure you won't mistake with O. Okay, we have that. Are we good here so far?
Yes.
Okay, so now we're going to looking at how we use that for linear equation. And I'll show you what are the rules we use. Okay, so this is pretty simple one, 2x plus 4. And a lot of times, if we just in middle school, elementary school, you say, okay, x equal to 2. And we say, oh, why? Why is that case? And we can say that 2 times 2 is 4, which is, it's good. It's called verification. Verification. We just basically is verifying this solution is true. And we can do that. But the question is this the only solution? And that becomes even harder. Could there be any other solutions for this equation? And we probably have a hunch that it is only one solution, but how do we know? Because if we just run out, check every number, and there's no way we can do that, because we have infinite number of numbers. So the only way to prove this is the only solution, then we have to follow by the rules. So here's the rules we are using. So the first thing we do is we're going to multiply the reciprocal 2 on both sides. And we know that we're following this rule. If A is equal to B, then A times C equal to B times C. So that is the rule we are using. And so this has to be true, given this is true. We are not saying if this is true, we are saying that this is given. We are saying if this is true, a number times 2 equals 4, that equation, then we know this has to be true. And then if that's the case, we know half times 2 is 1, because remember we said what number times its reciprocal is 1. So we have 1 times x, and the other side is easy, it's a number. Number is actually easy to do. But when we're dealing with symbols, we have to make sure to follow the rule. And we also know a times 1 is a, so now we know x is equal to 2. So this way, and we follow the rules, the only solution we got by following the rules is x equal to 2. So we know this is the only true solution. And sometimes we might make a mistake during the process. That's why we also need the verification by plug the 2 back in there. So we know 2 times 2 is 4, so it's verified. And this process is, you can see the progress of step by steps, and that's what logic is that if something is, this is A is true, then if something is true, then the other thing is true, because they have this relationship. So that's why, that's how we're solving like this. Sometimes in school, they teach you the process without telling you what the rules we're following. That becomes a problem, because we're not really teaching students like how to do, you mean in terms of how to use algebra, but we only tell them one particular example and one process, and that way the student will forget, but once they understand what's going on, that becomes pretty easy. You don't even have to memorize it. Okay. All right. Are we good so far?
Yes.
Okay. So any questions you can ask. Okay. And I'm going to show you another example. And this example is we're dealing with fractions. But remember, when we're dealing with the rules, we said all the rules apply to all numbers. So starting to apply to fractions. So what we're going to do, we know, so we have 2/3 times number is half. So what we know, we can multiply the reciprocal. The reciprocal of 2/3 is 3/2. So that's reciprocal. And then we have to multiply exactly the same thing on that. And so that's a rule, is if A equal to B, then B times C is, sorry, A times C equal to B times C. So that's what we use. And then we say A times 1 over A is 1. So therefore we got 1 times X equals 2. Now this is just simple fraction multiplication. And then that's basically things we learned in elementary school. So 2 times 2 is 4, 1 times 3 is 3. That's easy. Then we know 1 times x is x, so therefore x is 3/4. So now we proved this is only true solution. And we can plug this back, the value back to this equation and check it and verify it. Okay, are we good here?
Sure. Yeah.
Okay, so I'm going to make to the more a little bit more complicated linear equation. So now this is a kind of more general case. And we are trying to get this. So in order to get rid of this, we need to get rid of this and get rid of that number. And I kind of like when you're unwrapping a gift, right? When you're wrapping a gift, you get bag. And so inside the bag, you get some piece of paper. And so you have to take the paper out. Then you have to take what's inside, probably in a box, and take it out. Then you have to open the box, and then you get the present inside. So solving the linear equation kind of like that is that we need to get rid of this, kind of like unwrapping it. We need to take this out. It's kind of like open the box, and then what's left is our gift. So let's go back. So how do we do that? So the first thing we're going to do, we have this, this is given, this is called the premise. It's something given. And then what we're going to do, we're going to add -4, which is opposite of 4 on both sides. And that's a rule that if, I put the rule on this side, if A is equal to B, then A plus C equal to B plus C. We can add exactly the same thing on both sides. And now we know the equation has to be true, and because that's the rule here. And also we know a number adding its opposite is 0. So we know 4 plus -4 is 0. So we got 3x plus 0 on this side. On this side, 13 plus -4, we know that's 9. And then we also know a plus 0, that's the identity property, is a. So that means that's 3x is 9. And then we just use what we did before. We times 1/3 on both sides. And we know we can do that, multiply the same amount on both sides. The equation is true. Then 1/3 times 3 is 1. Then 1 times x is x. So therefore we have that. Then 9 times 1/3 is 3. So x equals 3. And that's a solution. And this is the only solution we have. And later on, when you see other equations, like quadratic equations, actually we're going to have more than one solution. And that's why very powerful when we use algebra for the rules. And we are not only find the solution, we find all the solutions. Okay. So are we okay on this one?
Yes.
Yes.
Okay, so now we're going to looking at this one. This is another example. And remember, we have this distributive property is we times B plus C, that's A times B plus A times C. And this one show you why the application of that is in this case, we don't know what the value of X is, so we cannot add 3 to it. So we have to break it up. So the real way to break it up is using the distributive property. So it becomes 2 times X, then 2 plus 2 times 3 is 6 is 14. Now on this part become easy. We know how to do that. We add the opposite of 6, get rid this value. So we got 2x left, and this side is we got 8. And now we actually I kind of didn't show you the rules, but just basically the rules we followed before. So you actually, when we actually doing those things, as long as we know the rule we're following, we don't have to write it out, but we have to know what rules we're using. And now on this side, then we just multiply half on both sides and half. So half times half, half times 2 is 1, 1 times x is x, then 8 times half is 4. So now we know we solved that solution. Okay, good?
Yes.
Okay, so now we got to the last one. Last example I want to show you is, and so far, remember that before that, let me can go back. We actually, this is called a constant. Those are constant, those coefficient, and those actually are specific numbers. And every time when we're trying to solving it, we have to follow the steps. So far, we had to follow the step and to find the solution. But the problem is each time we're facing a new problem, then we have to go through that process every time, and that definitely takes a lot of time. And as for practical, and also for theoretical reasons, and especially what interests to mathematicians is how can we save time? How can we just do it once and then we can just use that formula? Came up with formula, and then we can just use that formula. And that's the power, one of the applications, and actually very powerful applications of algebra. So I'm showing you this, okay. And we know that no matter what kind of linear equations, it's always have this form, is that we have a number as a coefficient, and we have another number as constant, we have another number as a constant. So those are fixed numbers. And what we are interested is how do we solve that and find the x, then we came up, then we have a formula we can use. So in this case, what we're going to do is we got a times x plus b equals to c. So we know we can add negative b on both sides. And we know that the rules we have. As long as we add in the same amount, we are good. And we know b plus negative b, a number minus a number, doesn't matter what letter, it just means a number adding its opposite is 0. So we got ax plus 0. On this side is c plus negative b. Now, on this side, then, we know it's ax. On this side is, keep that c plus negative b, which is the same as c minus b. Sometimes people write like that. And then we're going to multiply the reciprocal of the A, and then this side is 1. This is 1. 1 times x is x. And then on this side is basically C minus B divided by A. So now we came up with a formula, and we all proved this. We just proven that the formula is correct, is true, is correct. So then we can just using it. So now we can go back and say, okay, now we know the formula. We worked it out. It's simply x is B, is C minus B over A. Now, if we want to solve this equation, then we don't have to go through all the process again, all the steps. We just plug in. So we know in this case, C is 9, B is 3, minus 3. Our A is 2, So we got 6 over 2. That's 3. So we know x is equal to 3. So that's pretty easy. So we just plug in the formula. And we can also do another one. So another one is we got 3x minus 4 equals negative 2. So, and remember our form is here, is something adding ax plus that. So make sure we follow this template. So this actually is 3x plus negative 4. So our b is negative 4, and our c is negative 2. So therefore, our c is negative 2, then minus negative 4 over 3. And so now it's become negative 2 minus plus 4 is 3, then that gave us 2 over 3. So that we find the solution. So we don't have to go through all the step again because we already proved it by doing this. Okay?
Makes sense.
Yeah.
Any questions?
No, not on this.
Okay, all right, cool. All right, so next one will be our final lecture, and that one we're going to talk about algebraic expression and how do we actually operate on those expressions. And because when we dealing algebra expressions, we're going dealing with variables, and so how do we work with those variables? And in order to do that, we have to follow all the rules. Okay, all right. I'll see you next time.
Awesome. Thank you, Dr. Ping.
Oh, you're welcome. Yeah, good night.
Good night.